Hello guys and welcome back to my channel. It's Abed here. In the previous video I walked over some terminal commands and today I will continue with further commands. And by the end of this session I hope that we will finish everything related to Ubuntu command wise. And I want you to understand one thing guys. The commands inside Ubuntu are nearly endless. So I can't go over every single command here, but I just want to go over the most important ones that you will use later on whenever you are surfing or doing anything inside Ubuntu. And especially in the next videos, you will find these commands useful when we work with some robotics related softwares like Russ, the robot operating system, Gazebo, simulator, and Move It, and many other type of softwares. So after making this clear now, let's get started. So first, open your terminal, and as usual, I have prepared a file that will guide me through the session today. All right, now we are ready. I have already talked about the find command in the previous video, and this was a very powerful command when it comes to searching for a file or a directory. But what if I want to search for a certain word inside a certain file? Then find will not be useful. Only grep will be useful in this case. Now, before exploring the abilities of such command, let me change my directory to desktop directory 1. And this is a directory that I have created before this session. So as you can see, I have populated it with many files. Let's say I want to search for the word function. Okay, so I write grep followed by the word that I will be searching for, and I need to specify in which files to search for this word. In this case, I want to search in all the files in the current directory. As you can see, the system returned all the words function and along with the files where the system found these words. So as you can see, the system found the word function in file 1, in file 2, in file 3, and file 4, etc. And like many other commands, you can use different arguments with the grep. Let's say you want to search while ignoring the casing. Okay, so in this case, let's say one of the letters is written in uppercase instead of lowercase. It will show up in the results. And you can also use the argument n to see the lines where the word function was mentioned. As you can see, here is, let's say, a word function. Here is the line where it was mentioned, and here is the file. And also, as you can see, the system returned a word function with f written in uppercase, which didn't show up for the first command when we didn't use I, right? Okay. So that's it for the grep. Now, let's say I want to use find and grep together. So how to use the combination of these two commands? First, we write find as usual, and we wanted to find files in the current directory. We specify the type to be F, and we specify the name while ignoring the casing, iname. Let's say I want to search in all the files with the .py extension, and then we can use the exec argument. Okay, the exec argument will take everything, all the files that the find command has found, and apply the command which comes after the exec argument on each of these files. So let's say I want to grep the word function. Okay, so this command will search for all the files with the .py extension while ignoring the case, of course, and then it will grab the word function inside these files. So let me use n, then I. The arguments I and n can be swapped, so you can use I before n or n before I, it doesn't matter. The order does not matter in this case. Okay. Okay, what went wrong? Yeah, I forgot about one thing. After the exec command, you need to write a couple of curly braces and the symbol, the sign plus. Okay, never forget about these. Now, as you can see, it returned all the words function. Okay, so as you can see here, and along with the correspondent files and the number of lines also where it was found. But in this case, it's not highlighted, as unlike what we saw by using the grep command alone. Okay, very good. Now let me clear this. Let's say you want to, sometimes you need to save the results of your command somewhere in a certain file. So what to do in this case? If you want to save, let's say, the output of this command that we just used a couple of seconds ago in a certain file. So we use the bigger than symbol followed by the name of the file that we need to create, and we need to store inside it the output of this command. So result.txt is not in directory 1, but now it will be created with the result of the output of the command grep and find inside it. So if we list now the content of the directory, we can see the result.txt. Let us open it with the nano editor. Okay, so as you can see, this is the output that we just saw earlier, and this is inside result.txt now. Let me exit this. Now, of course, if you write, let's say, again to this same file, the information will be overwritten. They will not be added to the information that are already there in the result.txt. So what to do if we want to add information and not replace them, not override them? In this case, we use a couple of the symbol, the greater than symbol, to append information. This is the term, appending. Now we are appending information to the result.txt. Okay, so if I hit enter now and I go to see the nano result.txt, I can find now that the results that we saw earlier were duplicated, because once I ran the command another time, the second time, the information are appended to the information that have already been there in the result.txt. Okay, now that is clear. Now, what if you want to write out into a certain file, and at the same time you want to see what you are writing to this file on the terminal? Okay, so you need both the terminal output and the output to the file. So in this case, you use, instead of these greater than symbols, the vertical line followed by the word T. Okay, as you can see, this is the output, and if I open up result.txt, now the previous information, the duplicated ones, are now replaced by the new output of this command. Okay, so the information were overwritten. Okay, and at the same time the information appear on the terminal. Now grep is clear, and of course you can read more about it using man grep. Now let me jump to another different idea. Let me jump to the parent directory here and clear the screen. Now, if you use Windows, I think you are already familiar with the task manager. The task manager is a software, let's say, that shows you what are the processes that are running on your machine, okay, even if you don't see them in front of you. And I know that I'm giving a lot of analogies with Windows. This is because I use Windows and I used it as my first environment on a computer. So please, the Apple guys, don't get offended. Okay. So just as I said, just like the task manager, the equivalent to that in Ubuntu is two commands actually. Okay, the top and the psaux. Now, what is the difference? We will see right now. Now, the top will show you the processes that are running on your machine, on your Ubuntu operating system in a live mode. Okay, so everything will be changing, everything will be live. Okay, and another thing, it is called top for a certain reason, because it will show you only the most important processes that are eating the big chunk of your CPU and your memory. Okay, so let me run this. As you can see, you have different columns with different information about the processes. First, you have the PID, which is equivalent to the ID number for the process that is running. Here is the user who created the process, and there are a bunch of information available. Here you have the percentage of the CPU and the percentage of the memory that is used by the process, the time elapsed, and the comment, okay, which is another type of ID for the process. Only this is by name and the PID is numerical. Okay, so these two types of IDs will be used later. Okay, now if you want to exit, you either press Q or Ctrl C. Ctrl C actually is pretty much used very frequently, and also it's used in many programming languages to, let's say, stop a certain program or stop a certain loop, let's say in Java or C++. Okay, so it's pretty common. So let's clear that right now. Now, what is psaux and what is the difference between psaux and top? Psaux will give you all the processes, and with no exceptions, all the processes that are running on your system, but it will not give it in live mode, unlike the top that gave live mode, and it just gave the top processes, not every single process. So PSX will just give you a snapshot about all the processes that are running on your system the second you execute the command PSX, okay? Okay, so as you can see, the list is quite a bit longer than the one we saw in top, right? Okay, so, but we have definitely, we have pretty much the same information, okay? The percentage CPU, percentage memory, PID, command, time, etc. Okay, now, what if I want to search for a certain process, a specific process that I know its name, and I want to find out if it's running or not, or I want to find out more information about it. So how to do this using top or using PSX? So you type in top, and then you use the vertical line. And this vertical line will induce a process called the piping. So piping is just like taking the command in front of the vertical line and apply to it the command that is right after the vertical line, and this is what we call piping. So you take top and then you apply grep xorg. All right. Now xorg is a process that is running in my system, and here I just want to know some information about this process only. Okay, so as you can see, the system will give me the information about xorg, the PID, the owner, the person who started this this process, and the elapsed time, and the process CPU percentage, etc. Now we can exit using Ctrl+C, and the same thing can be done using PSX. Can write PSX xorg, only then it will be just a snapshot and not a live mode. Okay, sorry, I forgot about grep. Yeah, so we have here the information, and we have two processes related to xorg. So the system gave me both. Okay, now what if I want to know the PID, which is like the ID number of a certain process that is running? Okay, so let's say I opened Firefox. Okay, so I just opened a window in Firefox. Now it should appear as a running process. So I can use a derivation for the command grep, which is pgrep, and this will grep the PID, okay, of the process that I specify. So this is the word P stands for PID, and grep. Grep PID Firefox. I think this is the command for the Firefox, and as you can see, it returned the PID of this process. Okay, so why do you need the PID and the command, or what we call the name of the process? Because let's say you want to kill a certain process. For example, sometimes when I need to install a certain software and I really need to do it in the moment right now, and I cannot. For example, the system tells me that an update is running and you cannot install this software right now, and the update will take like hours and I cannot wait. So in this case, I need to kill the process that is running, which is the update, to install my software, which is another process that needs to be run. So in this case, I don't know anything about the update process, neither its name or its ID. So in this case, I can run top, let's say, and I find its ID, okay? And I find its command, which is the name of the process. So if you write top, you can see the command right here, which is the name of the process and the PID, okay? So in this case, how to kill this process? So if I have its PID, in this case, it's 13693. Let me copy this, Ctrl Shift C. And now I can use the command kill 9, and then I will paste the PID of the process that I want to kill. So notice here that I have an opened window in Firefox, and if I press enter now, the window will disappear. I just killed the process. Let me open it again. And let me see right now what is the Now I don't know, I don't want to know the ID of the process, even if it changed, because right now I can kill it using another way, using its command or its name. Let's say we will use kill all, okay, instead of kill 9. And now I can use the name of the process instead of its PID in order to kill it. So it's Firefox. It happens that I already know the command for this process, but if you don't know the command, you can just write top and it will appear. For example, here it appeared, right? This is the command. So now I can kill it. Okay, so this is pretty much everything. So now you can you can search for words inside a file, and you can see what are the processes that are running using psaux and top, and you can kill processes whenever it's needed. So I think right now we went over all the necessary commands, and for the next videos I will introduce you to Russ. I will give you a brief idea about Russ. When you design a certain robot, you know that you will have sensors and actuators inside it, right? So these two components need to communicate together, right? So when a robot sees something, let's say an obstacle, it needs to move away from this obstacle, and the commands will be given to its motor to move away, to turn left, turn right, etc. So this communication, this brain, let's say, this role is played by Russ. Russ is just like the brain that communicates, responsible for the communication between all the components of the robot. So it's pretty exciting to work with Russ. You will see it has many features. It has many unique abilities. You will see it yourself. You will like it, I promise. And also what is nice about Russ is that you can use many other softwares side by side with it. For example, Gazebo Simulator. Of course, you know that before designing a robot, you need to simulate it, right? To see its behavior, to control it, to apply some control strategies on that. So you will use Gazebo Simulator. It is very useful for such things, and it is used side by side with Russ, okay? And we will go over Gazebo too. And you have other softwares like Move It. I don't know if you have an idea about the robotic arms. When you move a robotic arm, you need to perform some calculation, Jacobian and matrices and linear algebra, but all that is built inside Move It. So you can do that. You can apply forward and inverse kinematics in a very easy fashion. So everything is built in, and you just design your robot, you just simulate it, you apply everything you want, you play around with it before designing it and build it in the real world. So these are pretty much very exciting. It's very exciting to work with these softwares. So this is what we will talk about in the next videos. So I hope you guys found it very useful and beneficial, and you have learned from this video. And if you liked it, please support this channel by subscribing for more. And again, don't forget to hit the notification button. And I hope to see you again in the next videos.